Okay, let's say that we have a circuit. All right, let's power it with a battery, and we're going to attach a bulb, so we're going to send current through a bulb. And let's say that this bulb can only handle a certain amount of current or a certain amount of voltage. Okay, well, the tool that we have to limit the current through this bulb is something called a resistor. It's a component in a circuit that will essentially resist the current. So it resists how much current can flow through this circuit, which means that less current goes through this bulb. It also means that there's less voltage across this bulb. Because let's say that this is 3 volts, a 3-volt battery, or a 3-volt power supply. Now that there's 2 objects in it, for the voltage to drop across, some's going to drop here and some's going to drop here. Without this there, it's all going to drop across here. So it'll be a 3-volt drop here. It'll be a higher current. If we add in this resistor, then it splits the voltage and causes less current to drop through there. Okay, and this is a very common practice in building circuits. It's so common that resistors can be purchased for less than a penny each. Okay, they're very small components that look something like this, and they have probably 3 bands on them that have different colors, and we can read those bands to tell us how many ohms the resistor is, how much resistance it provides. And then they have tables that we actually use to read those. So here's a table. It's got all these different colors on it. Okay, it says it the first stripe, second stripe, third stripe. It kind of tells us how to read them. Okay, and then here's a resistor here. Okay, an example of one. So let me show you how to read one now. Okay, so here we have a resistor. It's really, really tiny. You probably can't really see it on this camera. Okay, so you have a chance to work with them in class. But this resistor here has 3 bands on it. I know you can't see them, so I'll show you what they say. The first one is brown. Okay, the second one is black. And the third one is orange. Okay? So we have brown, black, orange. So brown, if we look at our table here, says that the first stripe represents a 1. So I'm going to put a 1 right here. The second stripe is black. In the second digit, black represents a 0. So we have 1, 0. And then the third stripe represents a multiplier. Okay, so for orange, in the multiplier stripe, it represents times 1,000. Okay, so that's 10 times 1,000 ohms of resistance provided by this resistor. Okay, so 10 times 1,000 is 10,000, or 10 kilo ohms, okay, of resistance there. Now, we'll go ahead and verify that, okay, with the multimeter. So here's our resistor. I'm going to bring in the multimeter. So, in the multimeter, this is the area where we can measure resistance. Okay, there's a one that says 200, it says 2,000, 20,000, 200,000, 2 million, or 2,000,000. Okay, and for this one it says 10,000, and so we would want to put it on the 20,000 range because it's greater than 2,000 but less than 20,000. So let's go ahead and put it on the 2,000 range first. So if I put it on the range too small, what's going to happen is when I try to measure it, I'm just going to pinch the 2 ends here, and nothing shows up. Well, if I change it to the next setting of 20,000, and I hold the 2 ends, it shows about 9.85. Okay? Now, 9.85 is definitely not 10,000. Okay? But if you look very carefully at this thing, which again, you're probably not be able to see very well because it's so small, but the range we're set on says 20K. And so what that means is whatever the reading on the screen, we add a K to the end. So 9.85K ohms. Okay? Well, 9.85 kilo ohms is pretty close to 10 kilo ohms. Okay? Now, what you're going to find on the resistor is there's actually 4 stripes, and we didn't talk about the 4th one yet. This resistor has a 4th stripe that is gold. Okay? What that means is, if you look here, where we see gold as the fourth stripe for tolerance, it represents 5% error. Okay? What it means is that this resistor is rated at 10 kiloohms within 5% of that. So 5% of 10 is 0.5. So that means that it's going to be between 9.5 and 10.5 kiloohms. And you can see that when we measured it, we were within that range. Okay? Now I'm going to give you one to try. Okay, so here I've got another resistor for you. Again, I apologize that you can't see it on here, but it's got 3 bands. The first band is brown. Okay, the second band is black, and the third band is green. Okay, using this table here, I want you to figure out what the rating of this resistor is. Okay, go ahead and stop the video and find the rating. Now that you've found the rating for this resistor, let's go ahead and measure it. Okay, so I'll just start from the lowest setting on the multimeter. Okay, I started at the 200 setting. Let's see if it has a rating of 200, less than 200 ohms. You see it doesn't read anything. Okay, I'm going to change to the next one. Alright, I still don't see anything. Change to the next one. Still nothing showing up. And change to the next one. Still not receiving any kind of reading. Okay, finally, get to the last one. And it says about 880, and let me actually take my fingers off of it, because when you get to this high, your fingers can actually influence the results. Okay, so I hold these down, I get about 996. Okay, so I'm going to write that down, 996. Okay, and then if I look at the reading on here, it says 2000K, which means that's 996 kilo ohms. Okay, so 996 kiloohms is going to be 996,000 ohms. Okay, well, let's see if that's close to what we expected it to be. Alright, if you remember from the last one, we said that brown was 1 for the first stripe, black was 0 for the second stripe, and then now green is times 100,000. Well, 10 times 100,000 gives us 1,000,000. Okay, well, is 996,000 pretty close to 1,000,000? It is. Okay, so it's within our range of 5%. If it was 950,000, it would be okay. Or if it was 1,050,000, it would be okay. So brown, black, green represents a 1,000,000 ohm. We can also write that as 1 mega ohm. Okay, mega stands for 1,000,000. While you're at it, go ahead and measure the resistance of your body. Okay, touch your two fingers to the ends. See if it reads anything. So like right now, I've got my 2 fingers touching the ends. It doesn't read anything. It's actually because my fingers are very dry. Okay, so if I damp them and do it again, still nothing. There we go. So I get a value around 1 mega ohm. Okay, how the moisture of your skin, how dry your skin is going to affect what this reading is. You can see it's fluctuating quite a bit as how hard I squeeze on it fluctuates.